All right, hi everybody. The notes for today are 8.4. We're going to be talking about the fifth type of reason that you can say that two triangles are congruent to each other, and this one's called HL. Now it's important, anytime you use HL, HL can only be used to prove that two right triangles are congruent to each other. It doesn't mean you're going to use it every time it's a right triangle, but if you use HL, it has to be for a right triangle. So we define right triangle to be a triangle that contains one right angle. And so here's a picture of what HL looks like. H stands for hypotenuse, L stands for leg. So if the hypotenuse and the leg of one triangle that's a right triangle are congruent to the hypotenuse and the leg of a second triangle that also has to be a right triangle. Remember, the box means it's a right triangle. That means the two triangles are congruent to each other. In each of these four examples, we're deciding whether or not we have enough information to prove that the triangles are congruent to each other, and then we're going to give the reason why. So they're not all HL. It's the first and most important thing. I want you to be careful. Just because you see a right angle does not mean that you're going to use HL. Sometimes people make that mistake. These two sides of the triangle are congruent to each other, and they're 90-degree angles, so you know they're both right triangles. Because of the reflexive property, you can say that the shared side is congruent to itself. And so if you look at the triangles, you know that the hypotenuse is equal, and you know that the leg or the side of one right triangle is the same as the other. So for this first one, you can say they're congruent by HL. Look over here at this next one. So on this one, based on what we know in our class, we don't have enough information to prove that the two triangles are congruent to each other. We know that they're right triangles because of the box. We know that the legs are equal. This leg and this leg are congruent to each other. But you see how there's no markings over here on PR and on SU? We don't have enough information based on what we know in our class to prove that those two triangles are congruent to each other. So we just say not enough info. Let's see, on number 3, G, K, J, and J, H, G. So for this one, they mark that all four sides of the shape are congruent to each other. So that means these two sides are congruent to these two sides. And then because of the reflexive property, you can say the side in the middle is the same. And so because of that, let's see, we have side, side, and then side. So for this one, it's side, side, side. It doesn't matter that these look like right angles. If they're not marked, we can't assume that they're right angles. And on the last one, triangle EFG and triangle SQR. For this one, see how they're marked as right triangles, but HL is not the reason we prove that these ones are congruent. We don't know that the hypotenuse, the longest side of this triangle, is congruent to the hypotenuse or the longest side of this triangle. What we do know is that these two sides are the same, and then both of these angles are right angles, so we know they're both 90, so those are the same. And then both of these two sides are the same. So the reason that these two triangles are congruent is side angle side. You might want to make a note on your paper right here that says just because they're right triangles does not mean that it's always going to be HL. So we're going to go ahead and practice some proofs that use HL as the reason. This is also a really good opportunity for us to just practice proofs in general. So remember, whatever is given to you, this one has two things that are given. You can go ahead and look in the statements side of the chart and you can find the things that are given. So angle A and angle D are right angles. They tell us that's a given, so we write that the reason for that being true is given. And then the same thing with side AB is congruent to side DC. That was a given, and so we write that as a given. Now we have to go back and fill in the three reasons that we don't know yet so far. If angle A and angle D are right angles, that means that triangle ABC and triangle DCB are right triangles. So the reason that that's true is that's the definition of right triangle. We defined a right triangle to be a triangle that contained one 90-degree angle. Now this is important because you have to say they're right triangles if you're eventually going to use HL. So as soon as you see something saying that they're right triangles, that usually means that later on you'll use HL in your proof. To prove that BC was congruent to itself, that's this side right here, that uses the reflexive property. You see how this side of the triangle over here is the same as this side of the triangle over here. BC is congruent to itself because of the reflexive property of congruence. And then because we have enough now to prove that triangle ABC is congruent to triangle DCB, we know that they're both right triangles. We know that this leg is congruent to this leg, and then we know that the hypotenuse is congruent to the hypotenuse. And so the reason for this one will be HL. On question number 6, you have 3 things that are given to you. So they tell you that the 2 angles are right angles, that's a given. And then they tell you that H is the midpoint of segment GK, so that's a given. And then they tell you that FH is congruent to JK, and that's already marked on the picture, so that one's a given. So on this one you had 3 givens. Because these 2 angles are right angles, that makes triangle FGH, the little one over here, and triangle JHK, the little one over here, right triangles, and that's because that's what the definition of right triangles is. Anytime you see them saying that it's a right triangle, that means that you're getting ready that later you're probably going to use HL somewhere in your proof. If H is the midpoint of GK, that means that from G to H is the same thing as from H to K, and the reason you write down for that one is definition of midpoint. Midpoint means that it's a point that divides a segment into 2 congruent segments. Midpoint means it's in the middle, and so when you say that H is the midpoint, that means that the piece on the left is equal to the piece on the right, and that's because of the definition of midpoint. We were given that, and so we're done. Triangle FGH is congruent to triangle JHK because the hypotenuse of this triangle is congruent to the hypotenuse of this triangle, the leg of this triangle is congruent to the leg of this triangle, and both of the 2 triangles are right triangles. And so the reason that you would conclude for this one that the 2 triangles are congruent is because of HL. On this last one, we're given 3 things, so I went ahead and filled those in. I found them in my proof, and I filled them in. One thing about proofs that I want to make sure I mention today is that you get better at them with time. Coming up with the reasons can be tricky when you're doing these on your own, so just remember to have patience when you're trying them on the homework assignment. It might take a little while before you get them right. On this one, it tells us that segment MP is perpendicular to segment QR, and that means that MNR, so this one right here, and PNQ, so this one right here, are right angles. That's because of the definition of perpendicular. When 2 things are perpendicular, they intersect to form 490-degree angles. So, because they're right angles, that means triangle MNR and triangle PNQ are right triangles, and that's because that's what right triangles means. So that one is definition of right triangles. Should make these boxes a little bigger. So, as soon as you see it saying that they're right triangles, that means that you're getting ready that you'll probably finish this proof with HL too. But just remember, just because it's a right triangle doesn't mean it's going to be HL, but in this one it does. Let's see, N is the midpoint of MP, so that means that from M to N is the same thing as from N to P, and the reason why that's true is definition of midpoint. That's what midpoint means. And then we're given that, and so we're done. Triangle MNR is congruent to triangle PNQ because the hypotenuse of each triangle is equal to each other, the leg on each of the triangles matches up, and they're right triangles. So this one finishes with HL.